What's up everybody, welcome to another video. Hope you're ready to flex those brain muscles. In this video we're going to practice sketching graphs given statements, some of which are about limits. So in the past we've practiced finding limits given graphs. In this video we're essentially doing the opposite. I'm giving you a bunch of different conditions and asking you to sketch a graph of a function that satisfies all of these conditions. So this is your chance to check your understanding of limits. Pause the video, pull out a pencil and paper, try these on your own. We're going to go through 3 of them. Check your understanding. Do you really understand how these limit statements relate to the behavior of a graph? All right, let's jump right into it. F of -2 equals 5. That's a point. I can just go ahead and put it right there. There's a point at -2, 5. All right, what about this? The limit as x approaches 2 of this function is 1. So as x approaches 2, that limit is 1. I'm going to keep it as an open hole for now and draw a little line on each side, which just tells me we're approaching from both sides and getting closer to 1. All right, the limit as x approaches 4 from the right is 3. So I'm going to find 4. The limit is 3. So again, I'm doing an open hole and we're approaching from the right. I'm just going to draw a little squiggle there to remind myself, and I'm going to fill all this in later because I don't know all the conditions and I don't want to draw something and then have to erase it or forget to erase it and be wrong. All right, part D. F is increasing on the interval from -infinity to -2. Increasing. So sloping upward like this. So from -infinity all the way up till -2, the function looks like this. So I'm going to draw that for now, and if I have to erase it later, I will. All right, last statement. The limit as x approaches 4 from the left of the function is less than the limit as x approaches 4 from the right. So here's 4. All right, so that means there's a jump, right? The limit from the left could be something like this, and I'm going to fill this one in and leave the other one open. And that limit is less than the limit from the right. So the limit from the right as drawn is 3, which we actually had to have because of C. And the limit from the left is less than the limit from the right. All right, I think I'm good to go. I think I'm ready to fill this in. So let me do this, erase this. I'm going to connect these two. Let me connect these two here. Limit from the left is 2. Limit from the right is 3, so let me erase this, and I could just basically draw anything here. I can make it go down, make it go up. I'll make it go down like that. All right, now what can I do here? Well, it doesn't tell me anything about this interval. All right, so I'm just going to connect these two. Let me erase this part. I'm going to connect these two. I can make it look however I want. I'm going to squiggle it around like this. All right, now let's go through each of our conditions and double check. F of -2 is 5. Boom. The limit as x approaches 2 is 1. Absolutely. The limit as x approaches 4 from the right is 3. From the right, that is 3. F is increasing on the interval from -infinity to -2. That is true. And the limit as x approaches 4 from the left is less than the limit as x approaches 4 from the right. That's absolutely true as well. We've got a graph of the function f that satisfies all of these conditions. All right, let's try the next example. If you didn't pause on the last one, pause on this one. See if you can do it on your own. Use the video to check your answer. F of 1 is 3. Love starting with these because I can just confidently draw a point like that. The limit as x approaches 1 is -2. Ooh, okay. So that means that the function's defined at 1. It's defined as 3. But the limit as we approach 1 is -2. So this has to be a hole because it's defined way up there. It has to be a hole. And the limit, we're approaching from both sides. So again, I'm just going to do little lines on each side to remind me of that later when I finish this graph. The limit as x approaches -3 from the right is 5. All right, -3. I'm going to find 5 here, and we are approaching from the right. So I'm going to draw a little thing to the right. F is increasing only, F is increasing only on -5 to -3 and 1 to infinity. Okay, I might save that for last. Let me read the last thing. The limit as x approaches -3 from the left is less than the limit as x approaches -3 from the right. All right, we were already told as x approaches -3 from the right, that's 5. The limit from the left has to be less. So I'm going to define it down here at 4 and just make that little jump. And what else are we told? Let's go back to that increasing part. F is increasing only from -5 to -3, so let me deal with that now. So I'm going to put a little point here. So that means it's going to be increasing there. And from 1 to infinity, okay? Okay, this limit as x approaches 1 is negative 2. So we have to connect it down here. I almost connected it here and went on, but remember that limit statement here. So it's got to approach negative 2 as we approach 1 from the right. So increasing only on these two intervals. I'm finishing this up now. Boom, boom. All right, and it's got to decrease everywhere else. So I can draw this up like that. It's got to decrease from here to here, and then I think we're going to be done. We can go back through and check and make sure we satisfied all the conditions and we didn't miss anything. So it's going to decrease from here to here. All right, let's go back through and check. All right, f of 1 is 3. Boom, we got that. The limit as x approaches 1 is negative 2. Boom, absolutely. The limit as x approaches negative 3 from the right is 5. Negative 3 from the right, that is 5. F is increasing only on these two intervals. So from negative 5 to negative 3, we're increasing. From 1 to infinity, we're increasing. And on the other intervals, which are negative 3 to 1 and negative infinity to negative 4, we are decreasing. That's true. Awesome. And then the limit as x approaches negative 3 from the left is less than the limit as x approaches negative 3 from the right. 4 is less than 5. Boom. We're good. All right, let's try one more. Ooh, bunch of infinite limits. Limits at infinity. Good stuff. I like to go all the way down to here and start with these first. Functions being defined somewhere. Super easy to fill in confidently. F of negative 2 is negative 1. I'll put a point there. And f of 1 is negative 1. All right, let me put a point there. All right, let me go back to this first statement. The limit as x approaches 1 from the left is negative 3. So as we approach 1 from the left, it's negative 3. And it's already defined here, so I know this has to be an open circle. If I filled it in, it wouldn't be a function. We can't have one x value with two different y values. And we're approaching from the left, so I'll do a little bloop like that. All right, the limit as x approaches 1 from the right is infinity. Ooh, asymptote. All right, that means there's an asymptote. So I can do something like this. That was kind of terrible. I'll just do it like this for now. There's an asymptote. The limit as x approaches 1 from the right is infinity. Awesome. All right, the limit as x approaches infinity is 2. There's another asymptote, this time a horizontal asymptote. It's getting closer and closer to 2, the y values, as x gets bigger and bigger. The limit as x approaches negative infinity is 0. Okay, so we're doing something like this. I'm going to draw it below since I see like a point below here, a point below here. I think I'm seeing how I can put all this together. So I think I can just connect these two like this. Let me do this. Kind of terrible. Let me try it one more time. All right, a little bit better. There we go. So we have that vertical asymptote, that horizontal asymptote. We have this random point here, and I think I can just connect like this, and then I can connect like this, and I think that's going to satisfy all of the conditions. Let's go through and check. The limit as x approaches 1 from the left is negative 3. That's true. The limit as x approaches 1 from the right is infinity. The limit as x approaches infinity is 2. The limit as x approaches negative infinity is 0. And f of negative 2 and f of 1 are both negative 1. Negative 2, 1. Boom, we're good to go. This is a weird graph because the function's actually defined in the same place where it has a vertical asymptote. Is this allowed? The answer is yes. This can be a thing if we have a piecewise function. This doesn't happen with rational functions, but the function being defined at the point has actually nothing to do with the definition of a vertical asymptote. The definition of a vertical asymptote is a one-sided limit being infinity or negative infinity. That's the definition. Okay, so we do meet that definition. We do have a vertical asymptote, and that's honestly why I put this example in, because I love weird examples like this that break our intuition of like, oh, the function is never defined at a vertical asymptote, or it never touches, or that sort of thing. Not necessarily true when we have crazy piecewise functions like this. Hopefully this video helped. I had fun making it. Like, comment, subscribe, do all that stuff, and most importantly, keep flexing those brain muscles, and I'll see y'all later.